A line, a capital AB has its NDA 20 mm above HP and 15 mm in front of VP. The other end, capital B, is 60 mm above HP and 45 mm in front of VP. The distance between the end projectors is 70 mm. Draw its projections, determine apparent length and true inclinations. Now here, the NDA is 20 mm above HP. So the above HP distance of the NDA is, looking from the front view, will be able to see, and when it is projected, that will be seen in the vertical plane. So this becomes A dash. Similarly, 15 mm in front of VP. So when you look from the top view, the distance in front of VP is seen, and when it is projected that point onto the horizontal plane, when it is projected by looking from the top view, that image will going to see on the horizontal plane. So you're going to get this 15 mm in front of VP. Similarly, the other end B is 60 mm above HP. So this distance above HP is 60 mm of the other end B. So when you look from the front view, the image will be on the vertical plane. So from XY line, you measure the distance of 50 mm, 60 mm, and draw a horizontal dash dot line, which will going to be the locus of B in the front view. And 45 mm in front of VP. When you look from the top view, the distance in front of VP is seen. That distance, when it is projected, it will going to fall on the horizontal plane. So that line will going to become the dash dot line, which will be the locus of B in the top view. The distance between end projectors is 70 mm. So we have the projector A here in the vertical plane and also in the horizontal plane. Similarly, when you see from the front view, we will going to have this end projector, this line, which will be here, which is at 70 mm. And similarly, when you look from the top view, the distance of this end projector will going to be seen on the horizontal plane. So this is the line which we will going to get this as the end projector. So from here you draw a horizontal, from here you measure a distance of 70 mm in the vertical plane and draw a vertical projector such that that will going to cut the locus of B in the front view at this point. So that will going to become small b dash, and then draw a horizontal, draw an inclined line join between A dash and B dash with a dark line. So which is that line? That line is nothing but this capital A and capital B. When it is looked from the front view, that image will going to be falls on the vertical plane. Similarly, when you look from the top view, we can see the distance of this end projector from here. So that will going to be seen on the horizontal plane when you look from the top view. So that distance is from here to here. So from this vertical line, you measure a distance of 70 mm and mark this point and draw a vertical projector such that it will going to cut the locus of B in the top view. So this will going to be small b, then join A to B with a dark line. So because this is the actual line which will be able to see both in the front view and also in the top view. So now we need to find out the true length. True length, since we need to find out the true inclination, so obviously we need to find out the true length. So first we are going to find out the true length in vertical plane. If you want to find the true length in the vertical plane, you have to make the line parallel to VP. So the line which is in space is capital AB with A as center. Take the radius of AB and rotate such that the point B is rotated such that the point B is made to be in front of VP by 15 mm, but still that line should be above HP by 60 mm. So with A as center, by taking the radius of AB, rotate the point B such that B is also in front of VP by 15 mm, which is 15 mm, so that both AB1 will be in front of VP by 15 mm. So now the line AB1 will be parallel to VP. So when it is projected, that is when it is viewed from the front view, the image will going to fall on the vertical plane. So that point will going to become B1 dash, and this will be capital A dash, small a dash. So join A dash to B1 dash with a little bit thicker than the projector line. So this will going to become B1 dash, and since it is parallel, so you will want to mark this as capital B1 and measure the true inclination with respect to HP, which will going to be theta. That is what they have found. Now, so when we are rotating like this, when you are rotating in space from B to B1, so obviously the image will also rotate in the horizontal plane. So that means when you look from the top view, this point B is rotated such that the B moves from B to B1 such that both AB1 will be parallel to VP. Since AB1 is parallel to VP, so we are getting the true length in VP, which will be A dash B1 dash. Now we will go to find the true length in HP. So true length in HP we can find only when you are make parallel to HP. So how to make that parallel to HP? So we have to take the line which is inclined to HP. So which is the line which is inclined to HP? That is the front view distance, which will going to be A dash B dash. Which is that line? That line is again, you take this capital AB. So now A is above HP by 20 mm and this B is above HP by 60 mm. So you make that point B also above HP by 20 mm. So how to make that? With A as center, take the radius of AB, you rotate such that B is also be above HP by 20 mm, such that this point B still in front of VP by 45 mm. So that capital AB2 will going to be the parallel to HP. So when you want to make that line parallel to HP, so here with A as center, AB as the radius, you rotate such that B will be above HP by 20 mm. So now the line AB2, that is capital AB2, is parallel to HP. Since the line capital AB2 is parallel to HP, when you look from the top view, it is projected onto the horizontal plane, that is B2, that is small b2 will be able to get that point, which will be the which is parallel to HP. So you are going to get the true length in HP, which is small ab2. But when it is rotated in space, what happens in the image? The image is also being rotated in the vertical plane. How? With A dash as center, A dash B dash as the radius, you draw an arc such that A dash B2 dash will be parallel to HP. Since A dash B2 dash is parallel to HP, so we are getting the true length in HP. So which is that line that is been projected here, and then we are projecting this point here, so that you will going to get this line AB2, and this will going to be the locus of B. So this is how we will be able to find we will be able to analyze this three-dimensional sketch. Now we will going to do it on the sketchbook. So to do that, first we will going to mark the XY line and mark VP and HP. So first we will consider the NDA 20 mm above HP. So the 20 mm above HP is seen in the vertical plane. Vertical plane is above XY line. So from the XY line you measure the distance of 20 mm above XY line and draw a horizontal line. Similarly, 15 mm in front of VP. In front of VP is seen in HP. So from XY line you measure the distance of 15 mm below XY line and you draw a horizontal line. And consider any point and draw a vertical projector such that it will going to cut both the lines at A dash and A respectively in the front and top view. So you mark this point as A dash and you mark this point as A. Then similarly the other end B is 60 mm above HP and 45 mm in front of VP. So above HP is seen in the vertical plane. Again from the XY line measure 60 mm above XY line and draw a horizontal dash dot line, and you mark that as the locus of B in the front view. Similarly, 45 mm in front of VP is seen in HP. HP is below XY line. So from the XY line you measure 45 mm and draw a dash dot line in the top view, and find and write this as the locus of B in the top view. Then the distance between the end projectors is 70 mm. The distance between the end projectors of both A and B will be seen in the both vertical plane and also in the horizontal plane. So from here, from the vertical projector in the front view, you measure 70 mm, and from the vertical projector in the top view, you measure 70 mm, and draw a vertical line such that this projector will going to cut the locus of B in the front view at B dash and then at B here. So name this as B dash and name this as B, small b. Then join A dash B dash with a dark line and also small AB with a dark line. So now we know that this is the front view because the top view line is inclined. We know that this is the top view because the front view line is inclined. So this is how we can analyze this. Now we find out the apparent lengths, that is A dash B dash length and AB length, which has been found out here. Let us see after the solution. Next, this is actually the problem what has been given and we have written on the sketchbook. Now we need to find out the true length. We need to find out the true inclination. Since we need to find out the true inclination, so first we need to find out the true length. To find out the true length, you have to make the line parallel to any one of the planes. Suppose if you want to find out the true length in HP, so you make the line parallel to HP. Suppose if you want to make the line parallel to VP, true length in VP, so you have to make the parallel to VP. Now first we will going to find out the true length in VP. So first we are going to consider the true length. That means you have to make the line parallel to VP. So which is the line which is to be parallel to VP? The line which is inclined to VP. So the line which is inclined to VP is small ab. So with A as center, take the radius of AB by using the compass. You draw an arc such that AB1 is made parallel to VP. That is, both A and B1 will be in front of VP by 15 mm. So once we make that line parallel to VP, so we will go to find the true length in VP. So then from B1 you draw a vertical projector such that it will going to cut the locus of B in the front view. So you will going to get that point as B1 dash. So since this line, that is AB1 is parallel to VP, so we are getting the true length in VP. So since it's the true length, it means it is capital A and capital B. So you mark this as capital A and you mark this as capital B and join A dash B1 dash with a little bit thicker than the projector line. So that is and measure the angle as and denoted that angle as theta, which is the true inclination with respect to HP. Now similarly, we want to find out the true length in VP. If you want to find the true length in true length in HP, you make the line parallel to HP. Which is the line which has to be made parallel to HP? The line which is inclined to HP. Which is the line which is inclined to HP? Which is A dash B dash. Now with A dash as center, take the radius of A dash B dash by using the compass. You rotate such that B dash will be above HP by 20 mm. So that means A dash B2 dash is the line which is parallel to HP. So since it is parallel to HP, we are getting the true length in HP. Since it is the point B2 dash, then you draw a vertical projector from B2 dash to the locus of B, where it will going to cut the locus of B at this point, which is B2. Then you mark this point as B2. Since this line is parallel to HP, so we are getting the true length here. So join between A and B2 with little bit thicker than the true length line. So since this line is parallel to HP, so AB2 is the true length. So we mark this as capital A and capital B and then denote this angle. Fine. Then by using the scale, you measure the distance from A dash B dash and also AB. A dash B dash will be 80.63 when you are doing it in CAD. When you are doing it in manual, it will be 81 mm. And AB, which is equal to 76.12 when you are doing it in computer, or when you are doing it in manual, it will be 76 mm. Similarly, by using the protractor, you measure an angle of the true inclination with respect to HP, which is theta, which will be 28 degree when you are doing it in manual, and when you are doing it in computer, it is 27.71. Similarly, by using the protractor, you measure the true inclination with respect to VP, which is equal to 5, which is 20.41 when you are doing it in computer, and when you are doing it in manual, it will be 20 degrees. So this is how we will be able to find the solution. Now we will going to take up the same thing, how it has been solved by using the stepwise. So in the stepwise, first what we have made, we have drawn all these things, that is drawing the locus of A above HP by 20 mm and in front of VB by 15 mm. And again the locus of B is above HP by 60 mm and in front of VB by 45 mm. So you have drawn these two locuses. Then you know the end projector A, and from this end projector A you measure the distance horizontally of 70 mm and draw a vertical projector which will going to cut both the locus at this point B dash and B, join A dash B dash and join small AB with a dark line. So we need to find out the true length in HP, true length in VP. So that means we need to find out the true inclination with respect to HP that can be seen in VP. So you make the line parallel to VP in the top view. When you make the line parallel to VP in the top view, so you are going to get that AB1 is the line which is parallel to VP, and when this projected, you are going to get A dash B1 dash, which is going to be the true length, and inclination with respect to HP will be theta. So we can find out A dash B dash and theta here in the first case. So that is what we have shown in this thing. So we made the top view line which is AB made parallel to VP. So you are getting parallel to VP here. Once you make the parallel to VP, when it is projected, that will be on the vertical plane, so that you are going to get the true length and its inclination theta. So we need not have to find the true length, but we want to find out the true inclination with respect to HP. Similarly, you take from the front view now. So we know the front view, you measure with A dash as center, take the radius of A dash B dash, you make parallel to HP. Once you make this parallel to HP, so we are getting A dash B2 dash is the line which is parallel to HP. When it is projected onto the top view, you will going to get the top view point onto the locus of B2. Then join A to B2, so that you are going to get the true inclination with respect to VP, which is equal to 5. So that is what we have done here in the 3 dimension also. With A as center, take the radius of AB, rotate such that B is also above HP by 20 mm. So that line will come parallel to HP. So when you look from the top view, that image will going to fall on HP. So now this can be seen here AB2. So which is the true inclination with respect to VP, which is 5. By doing so, what happens? The image in the front view is being getting rotated, so that B dash is rotated to A dash B2 dash, which is B2 dash is above HP by 20 mm, A dash is also above HP by 20 mm. So we made this is parallel to HP, and when this projected onto the top view, you will going to get the AB2, which is going to be the true length and its inclination 5 with respect to VP. So this is how in the stepwise we have explained. But this is not the one which we need to write. We need to write only this is the final solution which has to be written in the sketchbook. Thank you.